Good evening, everybody. On behalf of Professor Mahadevan's Students and Admirers Association, I invite you all for this webinar by Professor Panduranga Rao on Ramappa Temple. I find that many groups like Geo Heritage India, Indian Geoparks, Intact, Narayana College, Tirunanthapuram, and Guardians of Geo Heritage, Krishnuni Memorial Trust. They've all agreed, they've all showed interest in joining this one. I find more people from other groups than MASA. It's good. I would briefly tell about MASA before I request that Subbarao to introduce a speaker. Professor Mahadevan was working in Andhra University from 1945 to 1962. In 62, he died. And he was a man with a great vision. He started many subjects, new subjects in the department. You name it: nuclear geology, marine geology, sedimentology, geochemistry, mining geology, petroleum geology, coal geology. So many subjects he started. And he was a great visionary as such. And then he was also a great human being, very sympathetic, and people used to joke about him that his minimum marks he used to give is 90% and maximum is 99. But you could find the difference between 90 and 90.1. That much distinction. But then he believed that he should not play with the careers of individuals. That's why he was giving them high marks. And to perpetuate his memory and vision, some students of Professor Mahadevan, namely Dr. B.B.C. Sharma, Mr. M.V. Subramaniam, and Mr. K. Appavadhanulu, started this group way back in 2000 as such. And then this group every year it produces a volume called Geoforum. It's an article of geological interest and general interest also. It contains. And then we also gave fellowships to Andhra University Geology Department and Usman University Geology Department. And we also conduct yearly lectures in memory of Professor M.V.G. Subramaniam, the founder, president of this association, every year in different colleges. And we also conduct the great webinars like today's one. And I'm proud that Professor Panduranga Rao himself was a student of Professor Mahadevan, and he is also vice president of our MASA today. So I welcome all of you. I welcome him, and I will. Friends, you all know that recently UNESCO has declared Ramappa Temple in Telangana as one of the World Heritage Centers. And it was after a great effort by a number of people, and prominent among them was Professor Panduranga Rao. He has pursued it till the end, and he succeeded in getting it declared as a World Heritage Center. Professor Panduranga Rao was a student of Andhra University. He got his MSc from Andhra University in 1960, and then he joined Regional Engineering College. Then it was called Regional Engineering College. Now it is National Institute of Technology in Warangal. And then in 1974, he got his doctorate from Usman University. And then he continued there, and he has a passion for water resources management. And you talk about Sriram Sagar or any other, and then the drought-related programs of Warangal town. And you name anything related to water in that area, Professor Rao was there. And he has contributed significantly to the Kaleshwaram project of Telangana, which involves lifting of water from Godavari to quite huge heights as such at different stages. So he was responsible for that, and he is also not only Ramappa Temple, a thousand pillar temple in Warangal, a number of heritage centers as such. He is also one of the consultants for the Ayodhya Ram Janmabhoomi construction group. So,
you see, it's a great honor to be introduced the today's speaker, and I think I'm sure that I would assume that Dr. Parthaasaradhi has already given his name, and he was an alumnus of Andhra University, Dr. M. Pandurangarao. He was our class fellow of 1961 batch. I think he always had a very gentle way of handling his classmates also, and also a very calm-going fellow. And he comes from a very modest family. That is actually the greatness of Pandurangarao. Till now, I think he is now 80 years old. He has been maintaining the same status quo. One of the major things that he went from Andhra University to Warangal Regional Engineering College, and where he started his life really in the civil engineering department. So basically, all his efforts were really geared up towards the geoengineering, and he really made use of what our professor Sri Mahadevan has taught us, the common sense. So Pandurangarao has ample common sense, and that's what he has really used in all through the life. One of the major things that he has done, he in fact, where he lived in Warangal, he adopted really that city, twin cities, as his hometown, and then he revived the people. He taken up the major task of changing the structure of the lakes, and he went into really the geo heritage, and basically that is actually a great, really is in the floodwaters of Godavari, and then he has also made a magnificent project that connects up by a series of dams that he could really connect them up. He is one of the pioneers in that area. So from a level to the higher levels, he could take water, all the flood waters. That's a major contribution. And this is a world known setup that he made it in now the erstwhile Andhra Pradesh. Today it is Telangana. The other aspects are so many of his. The major contribution today, he is a hero because he, I think, really fought. He really lived with the heritage somehow or other. We must make Ramappa as a UNESCO Heritage Center. All my friends would really give a clapping to this great feat that he achieved. And this is how it's actually, at least for 10 years, he has been striving hard to make this a live project. That's led on behalf of all the associations here. I have really great pleasure in congratulating him and really salute him, rather, for this great achievement that he made. And let me stop at this level because we lost time, and let Panduranga Rao, today's hero, must come onto the stage. Thank you very much.
Andariki namaskaram. Good evening to all of you. It's my great pleasure and to interact with all my good friends, well-wishers, and admirers of my great Professor Mahadevan. Indeed, I am grateful to him, but for his help, I would not have made it into this level. He is such a great human personality. He helped me at every level, and I am really indebted to him for all that he has done for my progress. My salutations to my Guruji, Professor Mahadevan. I am happy that we are able to take our great Ramappa Temple into World Heritage, and it was inscribed as a World Heritage Monument. So we could succeed in getting the World Heritage tag, and UNESCO has inscribed as the 39th monument in India on 25th July at 4:45 p.m. We were all very exuberant, we were all elated because we have been trying for this for the last 10 years very rigorously, and for the last 40 years since I had a project from Archaeological Survey of India way back in 1980s. So I would like to present here to my good friends the geotechnical evaluation of heritage monuments. So the great Kakatiya kings have ruled this part of South India for over 300 years, from 11th to 14th centuries. They have created mighty irrigation projects. To commemorate them, they have created magnificent rock temples and also created township around them. This is what we call 3T concept: tank, temple, and township. In the early days, during 1980s, I had a research project from Archaeological Survey of India, geotechnical appraisal and evaluation of Kakatiya monuments. So this is the project. Along with me, I had another three friends, Professor Raghavachari, Professor Babu Shankar, Professor Samayazulu, and me. I was the coordinator. It was sanctioned on my name. We have done an excellent job of geotechnical investigations, and we have submitted the report, a research report prepared for the Archaeological Survey of India, Government of India, New Delhi in 1987. My other three friends, they have left me, they are in heaven, they are watching us. So I had the privilege of carrying on the mantle and continue the efforts that all of us made during 1980s. Now this is the panoramic view of Ramappa Temple, which was inscribed as the World Heritage Monument. And the site plan of Ramappa Temple. So you could see here the Ramappa Temple. And other temples adjoining, and the lake, beautiful Ramappa Lake. And this is the zone areas. You know, most of these temples under Archaeological Survey of India have 100 meters around it as totally prohibited zone, and then beyond 200 meters is the restricted zone. So we have to create the buffer zones, the core zones, as required by the UNESCO, and we have done that. So this is the view of the Lord Siva, Ramappa, Ramalingeshwara temple. You see the beautiful temple with Sikara and other adjoining temples. So this is the panoramic view. And you see here the pillars, the props, the sandstone props. And these great sandstone props were erected by Dr. Ejdani, the head of Nizam Archaeological Survey, more than 100 years back, to protect the cantilever, rock cantilever porticos. So his great intervention has helped us to protect the great Ramappa Temple. So here we have the meet on geotechnical appraisal and evaluation of Kakatiya monuments, 24th and 25th February 1991. And this is our then Director General, Archaeological Survey of India, Dr. Jagatpati Joshiji, and this is me and my other colleague, Professor Sastri and Professor Venkateswara. So we had, after 1987 detailed project report, we have organized this national seminar to deliberate, and it's only after this the impetus for taking Kakatiya monuments to different levels, protection, preservation, conservation of our great heritage started. So this is the book which I was referring to you, 1987. So this is the site plan, the Ramappa Temple, the Nandi Mandapam, Ramappa, the Ramappa Temple, the Nandi Mandapam, and the Kateshwara and Kameshwara temples on either side. So this is we have conducted a series of investigations, the geophysical investigations, the resistivity surveys, the seismic surveys, seismic refraction surveys, and also we have drilled boreholes to establish the subsurface geology. We have integrated the refraction surveys, the resistivity surveys, and the seismic surveys. Here we have a portable seismograph. This is way back in 1980s. This is me, and we are now doing the survey in the field. This is 1980s photograph. And this is the lineament map which we have prepared in that particular period by using satellite imageries of Landsat and SPOT, of French satellites and US satellites. And this is our great Ramappa Temple, Ramappa Lake, the hills, the temple, and the various lineaments which we have derived through satellite data. So this is the cracking of sandstone beams and sandstone columns. Now you will find here the beautiful involvement of the great Sapatis by utilizing the locally available rock, and also they have used the granites, the dolerites, and the most important foundation material, the sand. So you could see here the floor beams of sandstone beams have undergone total breakage, total failure, and has a settlement. Now you see here the borehole locks which we have done, and the soil profile of the Ramappa Temple, and the cross section, the existing foundation details of Ramappa Temple, and the various engineering properties we have done in the laboratories. As I was telling you, we had experts in soil mechanics and foundation engineering, we have experts in structural engineering, we have experts in the transportation engineering, and we have experts in geotechnical engineering. So we have collectively done all this wonderful work, first of its kind in India. So this view of Ramappa Temple with bracket figures supporting the roof elements. We have nowadays beautiful RCC cantilever, but in those days they have rock cantilever, and you could see the rock cantilever projections, and these projections were suitably supported by these great bracket figures. Now you see the view of Ramappa Temple, the main entrance. We enter from the east side, and the Lord Siva is on the western side. Both north and south are open. This is what we call the single shrine. So you have only one Lord Siva, and the remaining three are open. And in front of it is the Nandi Mandapam, where the Nandi stays. This is Lord Siva. Let us pray for the prosperity of the entire world, because now it has become a World Heritage Monument. It is the property of all of us in the world. So view of Ramappa Temple with the props, you can see how beautifully the Dr. Yajdani has done this restoration work. The main entrance of Ramappa Temple, northern side, and this is on the southern side. You have beautiful elephants, and then the temple, and the sikara. You know, the sikara is made up of the beautiful floating bricks of the Ramappa Temple. In fact, for entry into World Heritage, the outstanding universal values have to be established. So they were questioning, there are so many temples, what is the uniqueness, what is the outstanding universal value of your Ramappa Temple? So we have projecting, normally they project art and architectural exuberance. but we have taken it, the engineering aspect, geoengineering aspect, geotechnical aspects, the construction technology of the great Kakatiyas, and how they have created the floating bricks where it was the necessity, and how they have created the sandbox technology, how they have carved these beautiful Madanikas, Naganis and Raganis and whatnot. So this is the sandstone. They have used the sandstone, the local available Salawai sandstone, which our great geologists know. The Salawai sandstone is local available. They have carved in Salawai sandstones. They have also used the granites as roof beams, and they have used the dolerite, where the loads are very heavy. So they know the load distribution at that time. And they have also carved these rocks very beautifully with highly intricate carvings. Now you see here how the Ramappa Temple was in 1914, the Rudreshwara Temple, and subsequently the whole Gopuram. So these are the Sikara with floating bricks. You know, people who were visiting Ramappa Temple in those times, there used to be an irrigation channel going by in close proximity to the Ramappa Temple. So people used to pick up one brick and put it in the flowing waters and enjoy the floating brick going, like we used to enjoy our small boats in the rainy waters. Now all this has been totally modified, and we have created with lime mortar. We have purchased Sephardic bricks of a very low density, and we have used and created this lime plaster, which should survive for another 1,000 years. So this is the property of Archaeological Survey of India. They are the custodians. They are beautifully maintaining it. The NIT as former professor. So we were advising on various aspects of conservation and foundations. So this is the great floating brick of Ramappa. This brick with a density of less than water, 0.85 to 0.9, floats on water. It takes very high strength, more than 40 kg per centimeter square. Unlike the normal brick, whose density is about 2.2 grams per cc, and with a load of about 20 to 25 kg per centimeter square. So where was the necessity for these great sculptors of those days to create this lightweight brick, floating brick? Now here we have given the physico-mechanical properties of different materials, the dolerite, the granite, the sandstone, the floating bricks of Ramappa, and the normal brick. So the most hardest rock, which takes maximum strength, is dolerite, followed by granites, the sandstones, the floating brick, with a very high compressive strength compared to the normal brick. And they had site selection as well as the selection of the material for construction of the temple. So this is the Nandi Mandapam in front of the Lord Siva, the main entrance of the eastern gate. And this Nandi Mandapam was totally destroyed, and Nandi was kept inside the temple premises when we were investigating in 1980s. Now we have designed the entire foundations for this Nandi Mandapam and gave it to Archaeological Survey of India. They have rebuilt this Nandi Mandapam with the available sandstones and brought back the Nandi which was inside the temple and put it here in their own place. So this is our great contribution of RUC by designing the foundations and restoring the totally destroyed, collapsed Nandi Mandapam. And this is done by great ASI, Archaeological Survey of India. Now here you would see the floating brick of Ramappa. Geotechnical aspects. Now you see the beautiful floating brick. We have taken two bricks, one the normal brick, the other is the floating brick. We have kept that brick in waters. The brick of the normal brick with the 2.2 density, as we have put it in the glass, it sank. And the other brick, the Ramappa brick from the Sikara of Ramappa Temple, it is floating. Now you see the great contributions of the great sculptors Now, why did they create this brick? Obviously, they must have felt at that time, 800 years back, if they use the normal brick, there will be heavy load on the foundations and the total structure may undergo settlement, maybe sometimes a differential settlement, and resulting in the collapse of the whole temple. So they have thought that we should reduce the load on the foundations by decreasing the weight. So that is how they have selected the floating bricks and created the floating bricks. So this is the manual which we have done for the UNESCO. This is the crest jewel of Ramappa Temple, authored by Madam. I also gave one chapter in it. This is the Kakatiya Heritage, which is authored and edited by me. And this is the Kakatiya Dynasty, the coffee table book, which all these things were sent to UNESCO by the Archaeological Survey of India. Here, I have to mention the various important personalities and institutions responsible for doing this excellent job. Now you see here the real floating brick. Now you see that is the normal brick which I am putting in the glass of water. Now you see the brick sank because its density is 2.2 to 2.3. That is the floating, that is brick which floats on water. And the strength, as I mentioned, the strength of the Sikra brick is about 40 kg per centimeter square. This is about 20 to 25 kg per centimeter square. So I was giving a video clipping to our Enadu, Varangal. So I'm really thankful for the press, especially Enadu, who have shown to the world the beautiful the floating bricks of the great Ramappa Temple. Now you could see the live demonstration of the floating bricks. The same thing I have performed in the ICOMOS committee on 22nd November 2019 in Paris, along with my other friends. Mr. Paparao, a former IAS officer, and my co-trustee. In fact, both of us have started this Kakatiya Heritage Trust in 2009 with the main objective of taking the Ramappa Temple into World Heritage. We have been working together since 2009 and we could finally succeed. So the same thing was demonstrated before the ICOMOS committee. Me, Ms. Paparao, and our architect, Ms. Ramamurthy, we were defending our Ramappa Temple before the ICOMOS committee on November 22nd, 2019 in Paris. Now you see the great Nandi, very beautiful. And you will find exuberant carvings in dolerite, the hardest rock. The type of tools they have used in the construction of this great Nandi, along with the other pillars, is marvelous. The metallurgical tools they have used in carving, such fine carvings, special mention is to be made about the quality of metallurgical tools they have used and the type of carvings. Even today, after 800 years, you find a mirror-like polish. Now, this is the Karteshwara temple on the northern side, which is completely made up of sandstones on the elephants. And then we have the inscription pillar in again same black dolerite with 4 faces. And this temple was consecrated on April 18th, 1213. So we have the Kakatiya Heritage Trust and the government of combined Andhra Pradesh. We have redone this consecration. We have reconsecrated the entire Ramappa Temple way back in 2013 on April 18th, the World Heritage Day. So this is the inscription pillar, which you find in the premises of the Ramappa Temple. Now you see the utilization of materials. They have used the sandstones, they have used granite, they have used dolerite for the superstructure, and for the foundation they have used sand. And also they have used lime wherever it is required. Now you see here the settlement phenomena. There is a settlement. In course of time, I'll show you that there is the floor beams are made up of sandstone, very huge cross sections. So these are all the settlements in Kakshasana. In fact, the one which you go around the temple is what we call the Pradakshana Pada. After that, we enter into the temple, and this is Kakshasana where you can see, and you can see the settlement in the Kakshasana. So these are the settlements that have occurred. These are all from sandstones. So this, see, we have gone in for detailed geotechnical investigations. So that is the reason why we have kept so many slides. A settlement phenomena. So this is the central slab, the central hall. You will find here the dolerite pillars, 1, 2, 3, and 4. And you have a central slab. And the central slab, and we have 4 floor beams. And all these are all made up of sandstones, the Talwai sandstone. Whereas these are made up of the dolerite rocks. That means the load coming on them are very high, so they have selected these. And you see, this is the sandstone beam that has failed here. And because of the excessive stress, it is a tensile failure because of the 2 columns, the main load-bearing columns, and all the 4 floor beams have failed invariably because of the excessive tensile load the rocks were subjected to. And all these columns, all these dolerite columns are very well carved, exuberantly carved, and you will find even a fine thread can pass through these excellent columns. Now you can see the beautiful settlements, the failure of the floor beams and the settlement. Now here I have to mention, in spite of the the cracking of the floor beams, the sandstone beams have a very large cross section. The structure is still intact. Now this speaks volumes of the additional factor of safety. They have adopted extraordinary factor of safety. As I was mentioning, they have taken extraordinary precautions to minimize the load on the foundations by creating the floating bricks. Now similarly, they have also thought of creating extraordinary factor of safety. In spite of the settlement, still the structure is intact. Now you see the central beam, the central slab, different settlement in central hall and the beams. And see the failure. As you enter, you feel as if the whole things have been in crisscross. So this is the great engineering marvel of the great sculptors. So we have done a lot of work on the settlement phenomena, and now the whole system has been stabilized and no further settlement is taking place. We have done a lot of exercises on this, a lot of research. And now you see the main sanctum sanctorum. Now the same pillars, now the same the 4 dolerite pillars, which are very richly carved, and you enter into the sanctum sanctorum, and you will have the Garbhagriha where the Lord is located. The same settlement phenomena, the beams. We have done a lot of work on these beams. Now you see the roof slab supports. So this is what we call the cantilever. So they have a rock cantilever which has to be protected by these bracket figures. So these are the great bracket figures, and this is the intervention of Dr. Ejnani, where he has done a beautiful job of restoring this monument. But for this, the whole thing would have collapsed long back. The beautiful sculptures of Nagini in black dolerite, exuberant. Even today you find the metallic luster, mirror-like polish, the various Alasa Kanyas. So you find them around 40 around it. Dancing woman. Now this is the compound wall of the temple, and this compound wall is made up of the cavity wall. Now you have 2 leaves, the inner leaf and outer leaf, and over that you have the slab. So they have created this cavity walls all around the main temple as well as the prakara wall. And this gives a beautiful air conditioning effect in the sanctum sanctorum. View of the compound wall. Now, the conservation work in Ramappa Temple, the main entrance, after conservation of Pakasala, the Pakasala was in a bad shape, and the ASI has done this conservation work. And this is the conservation of Ramappa Temple after conservation of the Pakasala. It has gone total settlement. And this is another temple, what we call Siva temple, outside the premises. And you can see before and after. Now, same thing, the Ballalagudi, which is also outside the temple. And in fact, the Archaeological Survey of India and the UNESCO has suggested that it should be restored back to its normalcy, and we are going to do that shortly. And Siva temple, tourism, Ramappa temple, before the removal and after. And this is Kameshwara temple, which is in shambles. It has undergone total differential settlement. It has collapsed. If you go inside, in fact, people are not allowed to go inside because it is totally in shambles. And the ASI, Archaeological Survey of India, decided that we should remove it and restore it to its original glory. And that's why we have started removing this. Now, you see, we started removing the Kameshwara temple side by side from time to time. You see? So the pillars, the general view of east side of the Kameshwara temple, and then general view of east side of Kameshwara temple, where you can see the whole rocks are in shambles, and general view of the Kameshwara temple. We are on the Pradakshana Pada, where we go around the temple, where we go around the Kameshwara temple. And he is the Stapati, Mr. Siva Kumar, who is doing an excellent job. And this is our superintendent archaeologist, and he is our senior conservationist, Mr. Siva Kumar. Now we have started completely removing, dismantling the entire bit by bit by giving total inventory of the entire temple. Every piece is numbered. We started removing. Every piece is numbered, and we are removing it by lifting it very carefully so that they are not damaged. Now chedjas are being removed. Now with great care we have removed, and now you see here, totally we have removed except the central slab. Now this is the sand beneath the central stone, the central platform. This is the sand. This is what we call sand. This is our Stapati, and this is me, and this is the senior conservation officer of Archaeological Survey of India, Mr. Kumar. Now we have left it here. We have removed the entire material above it and stacked it elsewhere with well documented. And we have just kept it, even now it is there. We have just kept it because now we have to restore it very carefully by using anastolysis, rock restoration. There are certain techniques following the Agama Shastra, anastolysis. So this is an excellent example how the great Kakatiyas have built on sandbox technology. Wherever they want to build, they identify the area. They take about 40 meter by 40 meter area, approximately depending on the size of the temple, and excavate the entire material up to 2 to 3 meters depth, and remove the material and fill it with sand, consolidate the sand to its optimal density, and then over that you construct the temple, and the temple is very safe. Sand is an excellent foundation material. And it is not only an excellent foundation material, it is an excellent absorber of shock waves. So in fact, this was also subjected to a large number of earthquakes in the past, and it withstood the test of time in absorbing these great shock waves. Now you see, we are on the top. So he is the Stapati, and he is the director of archaeology from Delhi. He was then superintendent archaeological engineer, Mr. Jamwal, a very experienced archaeological engineer is Mr. Kumar, and I'm away, right away. And so we are inspecting the sand, and above the sand is the central sandstone block. Now we come to the entrance part, the gate, the compound wall and the gate. Now they're all, you can see the east gate, how badly it is damaged, the main entrance. Now because it is damaged, now we are entering from the west gate. Now we wanted to restore this, the east gate. So this is our team, and this is me and the superintending archaeologist and the Stapati and senior conservation Mr. Kumar. So we are inspecting the whole scenario. Now you can see the door jambs of the main entry from the eastern gate have been completely broken. Now we have mended it. Now you can see these are the two pieces broken, and we have mended it by introducing by stainless steel rods and then gluing it with heraldite. We have incorporated stainless steel rods and also glued it with heraldite and then restored it to its normal. And now you could see we are restoring the main gate. Now you see the beautiful, we are making the entry from the eastern side. Because it was damaged earlier, we made the entry from the western gate. Now we are restoring back to the eastern gate. Now this is our great Telangana, the remote sensing map with all the water bodies created by the great Kakatiyas. You can see here all the black ones are all. This is our Sri Ram Sagar project, the lifeline of water for Telangana and Godavari. This is the Lower Maneru Dam. This is our Ramappa Lake. This is Ganpur Lake, Lakhnavaram Lake, and Pakal Lake. In fact, you have here a beautiful drainage divide between Godavari Basin and Krishna Basin. I thought, because some of my friends are geologists, they are very keen to understand the satellite data and the remote sensing information. And the government of Telangana, the flagship program of the government of Telangana, Mission Kakatiya, is one of the beautiful programs the government of Telangana has taken up, and restoring the water bodies created by Great Kakatiya. We have identified 46,000 tanks, and we are now restoring all of them. Now this is the beautiful the Sri Ram Sagar, the Godavari and the Krishna, the Godavari Basin and the Krishna Basin, and the beautiful drainage divide separating the entire Telangana with Godavari and Krishna basins. Now this is the various tanks, various beautiful tanks and the contours we have created. And this is inverted pyramid. You see the beautiful drainage network. And this inverted pyramid will ultimately join in the responsible for creation of the Ramappa Temple and our outlet works and the Ramappa Lake and the few important clippings which I wanted to show from the print.
Tucked away in the interiors of Telangana is this 800-year-old Ramappa Temple, an architectural finally found its place on the World Heritage Map. The efforts for the same have been on for at least a decade now. This is probably the only temple in the country that's been named after the chief sculptor Ramappa and not after the local deity on any local traditional place here. It took 40 years for this temple to be built. Today, the print has come to Palampet village, where the Ramappa Temple is, to show you this exquisite craftsmanship, as well as the process that's behind that earned the temple a UNESCO Heritage Tag. This finest example of the medieval Deccan temple was inscripted as a 39th World Heritage Site in India by UNESCO late last week. Ramappa Temple, popularly known after its sculptor, is a 13th century temple built during the Kakatiya dynasty ruling between the 12th and 13th centuries. Particularly under the rule of Kakatiya king Ganapati Deva in 1213 AD. It took 40 years for the temple construction. The Ramappa Temple from an aerial view shows that it stands majestically on a 6 feet high star-shaped foundation. The temple, whose local deity is Lord Siva, is also known as Rudreshwara Temple, named probably after Rachela Rudra Reddy, who was the chief of the army of the Kakatiyas. The temple was built under Reddy's supervision.
Video Sunarandi? You're able to see the video?
Yes, yes, please. And
right.
The voice is also good.
Right.
Amidst the intricate carvings where each one tells a different story. For instance, there are 526 elephants on the outer walls of the temple, carved right next to each other, but one has to look closely to see that each one is different from the other. The elephants show the way to the inner shrine, and because the elephants played a key role in transportation of huge rocks back in ancient time, the importance was ascertained through these carvings. There are pillars inside the temple whose carvings are so perfect and delicate that even a thread can pass through it easily. The local guide makes sure that he carries a needle or something as delicate equivalent through a thread to show you these intricate carvings. There is a pillar of music in the temple where only a certain part of the stone generates music and the rest of it does not, which is still a mystery. Next to it are carvings of the Kakatiya era dance form Perini, which is now an ancient Telangana dance form. One of the main attractions, also a great source of information, is the basalt pillar with 204 lines engraved on all the 4 sides. These lines are on the history of the temple, the rulers, and the ministry at that time. In fact, the Palampet village was considered a city back then. There are idols of dancers, tribal ladies on the outer roof with such dainty craftsmanship. For instance, in this particular idol, shadow of the necklace worn by the dancer is shown on her stomach through the carving. Then, in another statue, where a thorn is being removed from the dancer's feet, even the swollen part of the feet is made visible. All these idols are made out of black dolerite rock, one of the hardest rocks in the world, and on the roof of the inner shrine there are carvings to depict different stories from mythology, starting from Lord Krishna to Ganesha. Another key attraction is the sacred bull calf Nandi, considered to be the gatekeeper of Lord Shiva, and it is built so tricky that it makes tourists feel that the eyes of the Nandi are always watching them irrespective of wherever they stand in the temple.
We have done about 5 years of intensive surveys, which include geophysical surveys like resistivity survey, seismic survey, and then we have also drilled boreholes to establish and collected the core samples and integrated them to assess the subsurface geological conditions. And we have identified the sandbox technology in 1980s that the Kakatiyas have done an excellent job of constructing the temple on a sandbox technology, foundational sandbox. In fact, the same sandbox technology which stood the test of time for 800 years in Ramappa, 1,000 years in 1,000 Pillar Temple, is a testimony to their engineering skills. And I have suggested the same foundation technology to our Ramajanmabhoomi temple in India. In fact, they were doing on concrete piles. So I went there and I found that they are doing concrete piles of 1 meter diameter, 40 meters depth, 1,200 piles. So I have discussed with them and stopped all the concrete work. Why the structure did not fail in spite of the earthquakes that have occurred in the past? Because that's very close to the Godavari graben, Godavari fault zone. So there were earthquakes. We don't know what was that intensity because seismological observations at the time. So we know there were. In spite of it, the structure has been intact. That's because of the sandbox technology which we have adopted. It's not only an excellent foundation material, but it's a beautiful shock absorber. It absorbed the vibrations created by these earthquakes and withstood the test of time. And then there is the exuberant carvings of black dolerite rock, the hottest rock in the world. The the architectural splendor, the way in which they have carved, even fine thread can pass through with mirror-like polish is another important consideration. And the settlement of the structure, in spite of the settlement, the structure is still intact, talking volumes of their extraordinary factor of safety.
Beautiful videos and also our explanation. Now we will put temple into World Heritage. What type of important components we have projected at the World Heritage? So we have to identify the outstanding universal value of our Ramappa Temple. Now, normally we propose the art and architectural exuberance, whereas in the case of Ramappa Temple, we have projected the engineering components, the geotechnology and construction technology of great Ramappa Temple, the floating bricks of Ramappa Temple, the sandbox technology of the Ramappa Temple, and the selection of type of materials they have used in the construction of the Ramappa Temple. And then the beautiful carvings, the metallurgical tools they have used in carving the pillars, in the carving the Raganis and Naganis, etc. is another important component. The extraordinary factor of safety, which they have thought at that time, has helped Ramappa Temple to sustain. So these are all what we call outstanding universal values. We have prepared the dossier. I was the coordinator of preparing the dossier. And along with me, my friend, Mr. Paparao, former IAS officer, my co-trustee, and our consultant, Mr. Satyanarayana. Three of us, along with the State Archaeology Department and the Archaeological Survey of India, we have done this great exercise. And from time to time, we were getting series of questions and suggestions from ICOMAS. And we have been incorporating all those important requirements and projecting them what they are needed. And as I have shown you, we have sent the Kakatiya dynasty, Kakatiya heritage, the Ramappa Temple, and a brochure to all the experts and our Department of Heritage, the secretary, the principal secretary, Mr. Srinivas Raju, and the director of archaeology. They have taken great pains in doing this beautiful exercise, and they wanted us to give videos in different languages. So you have done Arabic, Spanish, French, Chinese, Russian, and English. We have sent the videos in all these 6 languages, and we have created extraordinary ambience, and we were able to interact with them at different levels. And similarly, our Honorable Chief Minister has intervened. Our Honorable Chief Minister, Sri Chandrasekhar Rao Garu, has intervened and requested the Prime Minister of India to take special interest in projecting, in nominating our Ramappa Temple to World Heritage. Accordingly, our Honorable Prime Minister has taken very initiative and forwarded it to the UNESCO. So we really thank our Honorable Chief Minister of Telangana and our Honorable Prime Minister of India for this excellent job. Similarly, the Government of India, the Archaeological Survey of India, the Director General, the Additional Director General, they have taken adequate precautions at every level. For every moment, we were on video conferences, interacting at different levels and supplying the material required for the UNESCO from time to time. Now, similarly, the Ministry of External Affairs and our Honorable Minister of Government of India, Culture, Tourism, Kishan Reddy Garu, and the other Honorable Minister, along with their official staff, the secretaries, they have done an excellent job in interacting with different embassies. Similarly, our permanent delegation of India in Paris, Dr. Sharmaji, Vishal Sharma Garu, He has done an excellent job in integrating all the countries. And on the day of 25th July at 3:15, the nomination commenced. The nomination program has commenced. It went up to 4:45. For 1.5 hours, we were watching with nail-biting experience and how the countries were reacting. And our ambassador has done an excellent job in integrating all of them. And Russia supported us. And though in the beginning, Norway was not very comfortable, it has also supported us. And we were very happy. And 17 countries have supported unanimously. And we got the World Heritage Site. And they have announced that the Ramappa Temple has been inscribed as a World Heritage Monument, 39th World Heritage Monument. So I'm grateful for Lord Rudreshwara that he has given me a great opportunity of serving him, as you have been seeing for the last 4 decades. 3 of my friends who are not there, they are in heaven, they are blessing us. We have all been taking together. It's not an individual's performance. It's a collective responsibility. All of us, the Archaeological Survey of India, the State Archaeology Department, the Cocktail Heritage Trust, and other so many organizations have come together. And we were fortunate enough that we are able to prepare the dossier and presented it and update it from time to time. I'm very much thankful to my Professor Mahadevan, who has given me this beautiful opportunity of projecting our Ramappa Temple into World Heritage. I thank my friends, the President, Dr. Parthaasaradhi Garu, my classmates, Professor Subbarao, Ramrao, Chetty Garu, and all other friends who have seen. In fact, I had the opportunity of taking them to Ramappa Temple. They have seen how we have been working, and it's a great opportunity for all of us to work together and integrate the different components of science and technology. So we have integrated geology, geoengineering, soil mechanics, foundation engineering, structural engineering, and whatnot. And then we have made out this beautiful brochure and projected the great geotechnical aspects of the construction technology of Ramappa Temple, along with art and architectural exuberance. My friend has done an excellent job of writing a book on the Ramappa Temple, the crest jewel of the Kakatiyas, in which I have added one chapter on geotechnology, geoengineering aspects of Ramappa Temple and all that. So finally, I profusely thank all of you for giving me an excellent opportunity of projecting the Ramappa Temple into World Heritage, and to all of you. Thank you very much.
Thank you very much, Professor Pandu, for a very informative and illustrative lecture. I think we can have a few questions.
Yes.
Those interested may,
Hello, sir.
Dr. Shankar, please.
Yes, please.
Hello, sir.
Professor Panduranga Garu, Namaste and Dandalu. Hearty congratulations and compliments to you for your wonderful and dedicated efforts in getting the Ramappa Temple declared as a World Heritage Site. Compliments to you for your wonderful and dedicated efforts in getting the Ramappa Temple declared as a World Heritage Site. You had a vision and mission and you accomplished it. For all of us, we are so proud of you and your team. Just one small question.
Thank you.
You know, the two things that stand out in Ramappa Temple are, number one, the sandbox foundation. Number two, the floating bricks. My question is, were these first used in Ramappa Temple or was it already in vogue in those days?
Please repeat the question.
Yeah, my question is, the sandbox foundation technology, was it first used in Ramappa Temple, or was it already, used in some other structures?
Now, we have done this exercise in Ramappa Temple, Thousand Pillar Temple, Warangal Fort in 1980s, as I was mentioning. We were the first people, the NIT, or in those days it's known as REC, Regional Engineering College. Me and my friends, we have identified that the Kakatiyas have constructed the temples on sandbox technology, first of its kind. And all their temples, we have subsequently analyzed, all their temples stood on sandbox. And as long as the sand is confined in the box, this structure is very safe. By chance, if the sand finds its way out, it loses its density and superstructure will undergo differential settlement and it will collapse. This is exactly what happened in the case of our Kalyana Mandapam of Thousand Pillar Temple, where there was a major fault element which we have identified in the northeast-southwest direction, and the sand has escaped. And so the settlement took place and the whole Kalyana Mandapam collapsed, and now we are rebuilding it. The Atlas Survey is rebuilding it without using cement, iron, and concrete, following the same traditional sandbox technology, and they have given us for 1,000 years. Now our restored Kalyana Mandapam will go for another 1,000 years. So this is one of the greatest contributions of Archaeological Survey of India, where the NIT has given the technical advice for foundations, in which I am also a part of it.
Sir, the second question is very similar. The floating bricks, were they used first by the Kakatiyas, or was it already in use in other parts of the country?
No, we have not come across any literature. We found that they are the only people they have used it, and it is so beautiful that it is like our pumice, our molten froth of the lava. When there is a lava flow, there is a froth, and the froth gets solidified, and it's like a molten froth. It's also having a very high strength. We have done a lot of experiments in compressive, tensile, and shear strengths, and we found that this is able to take an excellent strength compared to our brick. Thank you very much, sir, for your comments.
Thank you so much. Namaste.
Professor Pandagarar, I have two of my friends have asked a question. One is Dr. Somnath Bhattacharya. He was asking whether the sandbox technology, that floating brick technology, was used at all in Ramasetu building of Ramasetu. Any work was done in that direction?
Actually, to my knowledge, to my information, I went to Ramasetu and I have seen Ramasetu, and this technology is different from that technology. And Ramasetu is a coral. It's a natural coral, the remains of the coral, and whereas this brick is an artificial material created by great Kakatiyas. So that is different, and this is different.
And then another question by Mr. Satyaprata Guha. He was asking whether local people were they involved in the reconstruction of this temple, number one. Number two is, what are the steps taken to increase the tourism in that area?
No, local people are always there. When the kings are ruling, they were all. In fact, I should say, the Kakatiya kings were very benevolent rulers. They have taken care of the common man, and in order to create agrarian economy and enhance the common man's upliftment, they have done beautiful water bodies. Ultimately, water is life. Water is divine. Water is great. So without water, nothing can develop. So rural development depends on water. And so the government of Telangana under Mission Kakatiya is now doing an excellent job of restoration of all the great water bodies created by them. So the local people are obviously involved in it.
Hello, sir.
Yes.
Can you hear? This is Dr. Vaishak from Srinarayana College, Trivandrum, Kerala. We are very much happy that we are able to listen to you, and we are about 60 plus students, researchers, and teachers participating in it. And thank you for your kind gesture for allowing us to participate and associating with this. Our congrats to your efforts, and also to the organizers of this very wonderful lecture series, and I would like to put to you that some of our students would like to ask some basic questions to you, because they are very much interested. And shall they ask now?
Yes, welcome. Thank you very much for your participation.
Welcome, sir. Yes, Sri Priya, please. Sri Priya? Yes,
Okay,
yes.
sir.
Yes, Sri Priya.
Thank you so much, sir.
I'm happy. Right.
Thank you, sir. Sir, my question is, what are the artistic specializations of Ramappa Temple, as well as what are the special criteria that were taken into considerations which gave the UNESCO tag to our temple?
No, we have different criteria. Criteria 1 and criteria 3 are projected. In fact, at one point of time, we have taken all the 3 monuments into World Heritage: the Thousand Pillar Temple, Warangal Fort, and Ramappa Temple. And we found that the Thousand Pillar Temple in Warangal and the fort in Warangal, they do not satisfy certain criteria. One important thing is they do not satisfy the 100 meters prohibited zone and 200 meters restricted zone and things like that. So we found that by tagging Thousand Pillar Temple and Warangal Fort to Ramappa, we may be on a different wicket. So we have delinked and projected only Ramappa Temple, which satisfies all the requirements. We have selected criteria 1. You can go through the document, criteria 1 and criteria 3, and the UNESCO has accepted all these important points.
Okay, thank you, Sri Priya. Asha Ashogan, would you please ask the question? Keep it back. Okay, fine. Yeah.
So my name is Asha Ashogan. My question is, why is dolerite specifically used in pillars construction?
Now, please repeat. It's very clear.
What?
No. Yes, you can repeat.
Yes, sir. In pillars construction.
The pillar?
Sir, why is dolerite specifically used in pillar construction in
Right. You see, as I was mentioning, they had an excellent knowledge of load distribution. So that's why we have given top priority to construction technology of the Kakatiyas and geoengineering aspects. So wherever there is a maximum load, they have used the dolerite. And they have not left it as it is. They have carved it, and we have seen beautiful carvings. Even a thread can pass through. So there, the maximum load is coming, and they have used the dolerite. And where they have used, where there is a lesser load, they have used granite, and still less sandstone. So we have all the 3 important rocks, the geological materials they have used, and they had an excellent knowledge. In fact, I was projecting that the need for, as I mentioned earlier, the need for creating a lightweight porous brick is they have visualized at that time, 800 years back. If they use the normal brick, there will be heavy load on the foundation, and the foundation may undergo settlement, and subsequently the structure may fail. So they have thought about all these things right the day one they wanted to create, which took about 40 years for complete execution. So they are excellent sculptors. They are excellent. They have excellent, extraordinary knowledge of the construction technology of the heritage buildings. So our heritage building should sustain for minimum 1,000 years. This is what I have been contemplating to our Ram Janmabhoomi Temple trustees. So when you are building the temple superstructure with sandstone, whose life is 1,000 years, the foundations, if they do it with cement concrete, whose life, as you know, the life of cement concrete is only about 100 years or maximum. If the engineered cement concrete, maybe 2 years. So we will have to design the foundations for at least 1,000 years, so that there is a compatibility of the foundations and the superstructure. So they must go together. That's exactly what the great Kakatiyas have done. We have seen them, we have tested them for nearly 1,000 years. They stood the test of time. So that's why I was telling, the modern structural designs are different from heritage structural designs.
Sir, two more questions. That why was performing arts, especially dance, uniquely portrayed in the temple? Why was there any special reason that a unique type of material was used for that, and also a specific dance postures were largely employed in the temple?
See, there is a beautiful treatise on dance, Nitya Ratnavali, the elephant commander of the Kakatiyas, Jaya Senapati, has written a beautiful treatise on dance forms. We have seen the various dance forms. Perini,
Oh,
a Perini dance form. So all these beautiful Naganis and Raginis were carved considering that beautiful treatise which was done in Sanskrit 800 years back. And that our Kakatiya Heritage Trust has translated it into English, and we have published it, Nitya Ratnavali, with original Sanskrit, and then this transliteration in English, and then the analysis in English. So it was an excellent book for all the dancers, and it was done by one of my friends. One of my friends, and so it is a very, very important book for all the dance people. So that's why you find those beautiful carvings in that particular fashion. Nitya Ratnavali.
What's sir, the name of that?
Nitya Ratnavali, a dance treatise by Jaya Senapati, the Commander-in-Chief of Elephant Army, and the brother-in-law of the king, Ganapati Deva.
Sir, Asha has one more question, the last question. Yes.
Unique compared to other Kakatiya temples?
So this is what I have been mentioning. The uniqueness is the floating bricks, the sandbox technology, the exuberant carvings with art and architectural, the selection of type of materials for construction, and the extraordinary factor of safety in protecting the monument for over 1,800 years. So these are all outstanding universal values. So this is not a single point, but there are a number of components that have gone in designing this beautiful structure 800 years back, and it is very comfortably lived for 800 years. And we are now restoring it for another 1,000 years for the posterity. Now, I would like to request our Masa friends also to interact so that they have their own few questions to my friends, my classmates, my colleagues, my geology friends.
Sir, I have one more question. Like, was this floating bricks available within the periphery or within the locality?
No, they are not available. We have completely prohibited, and we have completely sealed up. You have seen the completely lime plastered Sikara, and how it was in 1914 and how it is in 2005.
No, sir. That floating bricks, are they available within the region where it was built, or it was brought from other places?
No, they were created. You know, the bricks are manufactured. Okay. The bricks are manufactured. And normally the bricks are manufactured with silt from tank silt, and add husk and jute, and then burn it at a particular temperature. But whereas the great Kakatiyas have used some other organic resins, probably organic resins like gum karia, which is available in the forest, an organic resin, and mixed it with all these ingredients, and must have fired at a particular temperature where the organic resin got vaporized, leaving behind holes, number of porosity. It's a very high porosity of more than 40% and very low permeability, very, very low permeability. It is less than 1 centimeter per second, 10 to the power of -8 centimeters per second, such a low permeability like our black cotton soils. So we have analyzed all these things, and these are all the outstanding universal values of the great Ramappa Temple, which we have projected for the World Heritage Site.
So that was very much interesting, sir. It was very much a scientific knowledge that we. I think this knowledge can be used for further for our in the later period also, in the current period.
Yes,
also
certainly we can use it.
Thank you, sir. Thank you so much.
Thank you very much for participation.
Yes.
Ramrao.
Good evening, Dr. Pandu.
Table tennis, Ramrao.
Yes. First of all, congratulations to you for your nice efforts, and then finally you could get what you actually wanted, your desire. So I just want to ask you only one question. You have also been invited for the Ram Mandir temple at Ayodhya. For some advice, isn't it? If I'm not wrong. You have gone there for.
Yes, I've gone twice to suggest. It's not me. The Lord Rama called me.
What feedback you have given, and what from your experiences, and then from the Ramappa Temple.
Yes, I have mentioned. Yes. We have suggested to them, and they are now following a large number of our sessions, and we are very fortunate. I am very fortunate that Lord Rama has given me an opportunity to intervene at the right time. Had it been delayed, things would have been different. So it's Lord Rama's guidance that is responsible for me to go there, and we went twice. And there's also a Sarayu River, where Lord Rama used to take. It's a snow-fed river from Himalayas, and we have identified the paleo channels through our remote sensing. We have also suggested some remedial measures for minimizing discovering phenomena of the Sarayu River, and number of things. These are all things which go a long way in protecting and preserving the great monument which we are building to sustain for at least 1,000 years.
One more, are you planning for any further?
It's a continuous process. I'll be going again and again
for heritage.
I'll be going again and again. It's a continuous process. We will be. It's Lord Rama's wish that we should do something. If it is wish, we will do it.
Well, I think we'll close this one with this. For those people, I take the liberty of giving the email ID of Professor Panduranga Rao, so that if anybody has got any questions, they can contact him, and he will be happy to answer them. This is Professor MP Rao at yahoo.co.in.
No, not that. PR, please write down PROF RAOMP.
Sorry, I just the other way. At yahoo.com.
I'll repeat. PROF RAOMP.
Yeah.
Professor Rao MP @ yahoo.co.in.
Thank you. I request Mr. S. Satyanarayana to propose.
Before that, I would like to say that I am very grateful to all my friends, to our great professor, and my friend, Mr. Balakrishna, my friend, Mr. Balakrishna, who has done an excellent job. Because I am not an expert in this. My friend, Mr. Balakrishna, he has done an excellent job. He is in TRAC, Telangana Remote Sensing Center. My other friend, he is not there today. Dr. Srinivasreddy is the additional Director General of TRAC. So we have been doing the remote sensing of Sarayu Nadi and paleo channels and all that. Me and Srinivasreddy, we went there twice to do something for our Ramajanmabhoomi temple. So I am also grateful to my co-trustee, Mr. Paparao Garu, and our great friend, our consultant, Mr. Ramamurthy, and all other people who have helped in taking Ramappa into World Heritage. Thank you very much.
So, over to Mr. Satyanarayana, please.
Sir, namaste to everybody. I think I'm audible.
Yes, Shankarnayan Garu.
Yeah, namaskar Andy to everybody, and good evening to all of you. And Sri Parthaasaradhi, President of the Professor Madhavan's Students and Admirers Association, has assigned me the task of proposing the vote of thanks. I'm really pleased to present my vote of thanks on today's evening, where we had a very lucid presentation by Professor Pandu Ravi, and a lot of details he has covered. In fact, we have seen him. This is the third lecture I had, in fact. Once he had given a lecture in the MASA meetings. Then second time, last year, we about 15 members of the MASA, we went to Warangal. We had the opportunity of interacting with him for 2 days. And even at the age of 80 years, almost, or 78 then, about a year back, 78, 79, he took entire day, he was with us explaining the Warangal Fort, the 1,000-pillar temple, the Ramappa Lake, Ramappa Temple, intricacies involved in the geoengineering and geotechnical aspects, and also Vundavalli. And in fact, the time was very short. It was around 6:30. We returned to our hotel about, say, 9 o'clock or so, something like that. But Mrs. Pandu she also joined us, and it was a great pleasure to be with them. And the next day we had a lecture on the Telangana water resources as a memorial lecture he has given in the Karthik University. And later on, we his house, simple living. And we had a time to spend about an hour or so with them, with the family. And in fact, our Professor Subbarao, who came a little bit late to introduce him, but many in GSI, maybe knowing he was classmate of not only this Professor K. Subbarao, classmate of S.V.G. Krishna Rao, who is present in this, today's webinar, and also classmate of Dr. K.S. Rao, K. Srinivas Rao, and M.S. Rao. I'm taking only a few names. They are all classmates, very chummy, very blossom friends. And in fact, last year we tasted his lecture in the field, various types of styles followed. In fact, the time was very short. That's why he could not give more details for us. But thank you very much, sir, for your lucid presentation. And in fact, there are about nearly about 90 to 100% today attended. It's a good webinar all over India. Thank you very much once again, sir. And I thank Professor K. Subbarao, who has given a good introduction of his classmate friend. In fact, Professor Subbarao himself controlled his talk, introductory talk, because professor normally they take their own time, but today Subbarao, for some reasons, because he came late, otherwise he would have taken some more time. Thank you, Subbarao, introducing your classmate and others. And I would like to thank the audience from different parts of India who have participated and raised. But the time is not enough to clarify all our doubts and the contributions made by Pandu and other teammates. One thing he still remembers his other colleagues who have contributed a lot, and they are not with him. That really shows something, his gratitude to his colleagues. And finally, I would like to thank the team consisting of my classmate Ravi Kumar and others, Mr. Nageswaran, and I think Ramamurthy, all from GSI colleagues, and they have done an excellent job despite some initial noises from various quarters. They made the presentation made it very lively. Thank everybody. Thank you very much, sir.
Thank you very much. Thank you.
Thank you, sir.
Thank you very much, sir. Thank you very much, everybody, for participating in this one.
Ravi Kumar